Okay, section 6.4 is called special systems, but really there's nothing special about them. They're just talking about the different things that can happen when you're solving a system, and they're also assigning some vocabulary words to it. So I mentioned before in video 6.1 that when you're solving a system, when you have two equations, you've basically got two lines. And the only things that can happen when you have two lines, you're either going to have them at some point intersect, or they could be the exact same line, like then you'd have another line on top of it, or you would have the lines be parallel. So when lines intersect like this, you get one answer. When they're the exact same line, you have infinitely many answers because everywhere on this point is going to be an answer. And then when you have parallel lines, you have no answers because they never cross, and it's the crossing point that is the answer. So the vocabulary that goes with this is if you have a system that's said to be consistent, that just means there's at least one answer. So consistent means there's an answer, at least one. So these two are both said to be consistent. Now, because there's two things that are consistent, they break it down even further. Again, this is just vocabulary you really have to memorize. Independent is where there's one answer. So this situation is called independent. There's one answer. I always think one because one answer, you're independent. Then if you're dependent, that's this situation. It's where there's infinitely many answers. So both of these are consistent, but this one is consistent and independent because there's one answer. This one is consistent and dependent because there's infinitely many answers. The other thing that inconsistent. An inconsistent means there's no answer, and when there's no answer, you're talking about parallel lines. So these are the things that can happen with solving any system. When you're asked to determine if a system is consistent or inconsistent, there's basically two approaches. The first approach is if you solve and get them both in like this y equals mx plus b form, and then if a line, so for example, say my system is this, y equals 2x plus 3, and y equals 2x plus 5. Without doing any solving, I know that this system is going to be inconsistent. These are going to be parallel lines. The reason I know they're going to be parallel lines is because they both have the same slope. Since these both have the same slope, but they have different intercepts, that means they're parallel lines. And so I'm going to have an inconsistent system. Spelling that wrong. Inconsistent. Anyways, an inconsistent system, it means there's going to be no answer. The other way to figure out if you have a consistent or inconsistent system is just to do your normal solving. So you can use any of the methods. So your second way is to solve for variables using any of the methods we learned. You can do that by substitution, you could do it by elimination. So when you're solving using substitution or elimination, and when all is said and done, you end up getting something that says -1 equals 3. If you get a contradiction like this, you get something that just isn't true, that means there's no answer or no solution. This is inconsistent. And going back to that example that I made up, I don't remember my exact numbers. I think I had 2x plus 3 was the one, and then 2x plus 5 was the other. That could be wrong, but using this example, if I didn't notice that, oh, these have the same slope, but they're different lines, and I wanted to use the substitution method to solve this, I could just take this equation here and plug it in here for y. So I would say (2x plus 3 equals 2x plus 5. Sorry. So I plugged this answer in here. So this was my 2x plus 5. And that's going to equal 2x plus 3. Then you solve the way you would normally solve. So I'm going to subtract 2x from both sides. And I'm going to get something that says 5 equals 3. Since 5 does not equal 3, there's no solution. So whenever you solve a problem and you get something that just doesn't make any sense, that means there's no answer or it's inconsistent. The other weird thing that can happen when you're solving a problem is, let's say I have y equals 2x plus 1, and my other equation is 2x minus y plus 1 equals 0. And I just want to go ahead and I'm going to use substitution and solve this. So this equation here, I'm going to plug in right there. So I'm going to do 2x minus, make sure this gets put in parentheses because it's minus this whole quantity. Because then what's going to happen is you're going to distribute that negative sign. So you'll have 2x minus 2x minus 1 plus 1 equals 0. If 2x minus 2x is nothing, minus 1 plus 1 is nothing, I'm going to end up with something that says 0 equals 0. If you get 0 equals 0, or even if you got, say, 3 equals 3 or 4 equals 4, if you get a statement that is always true, it's some number equaling itself, this means you have infinitely many answers. So this is a statement that is consistent and it's dependent, because you have infinitely many answers, or sometimes your teacher will have you write that as all real numbers. So that is just a real quick recap on 6.4 special systems.